Hello. Now we are going to look at axial symmetry. So an axis we know would be the x-axis or the y-axis. So they're lines, they're axes. And a more useful name for these, though it's not the name we will formally use, is mirror symmetry. So in this type of coordinate geometry, in this type of geometry that we're doing, we are going to reflect shapes. We're going to reflect points through lines. So we're going to have a line on the page that's going to act like a mirror, and we're going to reflect the points that we're dealing with through that mirror. And we're going to look at how that works now. So if I have my shape here, my triangle at A, B, C, well, if I know the coordinates of my points, I know that A is at in the door -5, up the stairs 7. So in the door -5, up the stairs 7. B is at in the door -2, up the stairs 3. So in the door -2, up the stairs 3. And C is at in the door -6, up the stairs 2. So those are the coordinates of my points. If I want to reflect, if I want to do axial symmetry in the y-axis, or if, to put it more plainly, if I want to treat the y-axis, so the up and down axis, like it is a mirror, where would all of the corners of my shape, where would all the vertices of my shape end up? Well, if I think about myself standing here looking in this mirror, all of my points would go out as far behind the mirror as they were in front of it, and they'd keep going in the same direction. So I go out perpendicularly from the mirror, and I'd say, well, A is 1, 2, 3, 4, 5 points straight across from the mirror. So I would go 1, 2, 3, 4, 5 points on the other side of the mirror going in the same direction. So again, if I think about me standing at A and looking in the mirror, I would see my image in the mirror the same distance back away from the mirror, inside of it. So again, we're picturing the y-axis like it was a mirror we were looking at. And we would end up as far behind the mirror, looking like we were as far behind the mirror as we are in front of it. So again, we go in our 5 places on the other side, and this is called the image of A. And the way that we say that is we know we use capital letters for our points, and A with a apostrophe next to it is how we say the image of A. And can we do the same thing with B now? So we are just, if we go perpendicularly out from our mirror, from our y-axis, we're just 2 blocks straight across. So we go 2 blocks in. That would be our image of B. And C, we are 6 blocks out from the mirror, going straight across. So we just go 6 blocks out that way, and we keep going in the same direction. So I didn't start drifting up. I didn't put my point C up here. I'm going perpendicularly out from my mirror line, and I go out to my image of C here. If I draw in my lines, I can see that I have reflected my triangle. So just like if I was looking into the mirror, the part of me that would be closest to the mirror would look like it was closest to me in the reflection, in the image in the mirror. And I can see that that's happened here. So B was closest to my mirror line, and the image of it is also closest. And C was furthest away, and I can see that in the image it looks furthest away as well. So all of the intuition, all of the understanding that we have for mirrors works for doing this axial symmetry. Now, it doesn't technically need to be the X or Y axis that we're asked to reflect in, but that's the easiest one to do. But we always know we're going to go out perpendicularly from our mirror line, as far away from the mirror into the mirror as we were out away from it originally. So we go perpendicularly out from the mirror, and that's easiest to do if we're dealing with the X or Y axis, because we have all our nice grid lines to help us keep track of our distance. So we're going to fill in our coordinates here. So A was at -5, 5, 7. B was at minus 2, 3. And C was at minus 6, 2. And because of the way that we have reflected, what are our coordinates going out here? Well, now we are at 5, 7. And in the door, 2 up the stairs, 3. What has happened to our coordinates? In the door, 6, up the stairs, 2. Well, we can see that the signs of our x coordinates have just swapped because we have reflected in the y-axis. And this is a pattern that we can spot and that we could be asked about. So we know how to read our coordinates. Let's do the same thing for if we were asked to reflect in the x-axis. So here we were using the y-axis as a mirror line. Now we're going to use the x-axis as our mirror line and see what effect that has. So let's start with C this time. So we're going to reflect C through the x-axis. So now the x-axis is our mirror line. So we're going to go perpendicularly out from our mirror, and we can see that we've gone 2 perpendicularly away from our mirror. So we're going to go 2 behind our mirror. So that's our image of C. And A is 7 away from our mirror perpendicularly. So perpendicularly means at right angles too. And we're going to go 7 down here. And that's our image of A. And then our image of B is perpendicularly 3 away. So we have our image of B, and we draw in our lines. And we have our coordinates again. So this is at, B is at minus 2, minus 3. C is at minus 5, I should say. Minus 7. And C is at minus 6, minus 2. And if we write that in here, we can see that this time all of our y coordinates in our image, so we have our original point A and then our image of A when we've reflected through the x-axis, there we can see that all of the y components of our coordinates have changed sign. So they went from positive to negative because they were all originally positive. They're all now negative because we've reflected in the x-axis. So we can see the effect that this can have. Now, this pattern does not always hold. There's lots of different shapes that we could be asked to do reflections of, but it's important to try and spot these patterns. Geometry is all about spotting patterns, being able to understand the story of what it is we're doing. So we can now see our original object, our triangle, and it's been reflected in the y-axis here and reflected in the x-axis here. And we can see how that works, that we go perpendicularly out away from our mirror into the mirror, the same distance we were out from it. Now, that's one way of looking at axial symmetry or mirror symmetry. The other thing that can happen that we can think about is if a shape itself has a line of symmetry. So if we look at our rectangular box here and our square here, would there be any things like this? If you see the original triangle and its image, and we have the mirror line in between, if we folded this, if we imagine this was graph paper, was a folded piece of paper, we folded it on our y-axis, our original object, our original triangle, would fold onto our image. Well, do we have any lines like that where we could fold the shape onto itself on a rectangle? Well, we do. We would be able to fold it right down the middle here. And if we fold it along that dashed line, this corner would meet up with this corner would meet up with this corner, and the lines would all line up with each other. So we would fold the shape onto itself. So that would be an axis of symmetry, because that line there is like our y-axis. It allows us to fold the shape onto itself. And likewise, we could also fold it along this line here, and it would fold onto itself. This corner would fold onto this corner would fold onto this corner, and these lines would all fold onto each other. So those would be our axes of symmetry for a rectangle. Now with a square, we have the same ones, but we also have some more. Because the square has the same side lengths, if I fold it over on the diagonal, I would fold this corner onto this corner and these lines onto these lines. And I could also do the same thing on the other diagonal. So this takes a little bit of getting used to be able to spot your lines of symmetry, but all we're doing is picturing these as pieces of paper on a page and folding them onto themselves and saying, well, do all of the lines match up? Do all of the corners match up? And if they do, then we have a line of symmetry. And that's what we need for our axial symmetry, which we can also call our mirror symmetry.